Today we are adding into our notebook solving 1- and 2-step inequalities, and this is going to be on page 20. So pause if you need to take time to write that down. Okay, and then over here on your left-hand page, you're going to have a foldable. So you need to be looking at the side that has the examples on it. It has the 4 columns across, and you're going to cut along the entire outside on the dashed line. And then you're also going to cut where it has the dashed line in between these 2 outside table pieces. Okay, so if you make that cut, it will give you something that you can then fold in and close, and then you'll put the glue where it says glue here, and that's the side that you will glue down into your notebook. Okay, so pause go ahead and pause if you need to take time to get that glued in. Okay, but when we're talking about solving inequalities today, we need to make sure we're okay with our basic 1-step inequalities. What do we do to just do those inverse operations? Okay, so what happens if we're solving a 1-step inequality with addition? Okay, so to solve a 1-step with addition, okay, we are going to solve it just like an equation. So everything is going to be normal, just like an equation. If we see addition, we are going to undo that with subtraction. So we are going to subtract whatever number is on the same side as the variable. And remember, whatever we do to one side, we have to do to the other. So we're going to have to do that on both sides. So if we have something like y plus 8 is greater than or equal to -10. We are going to solve this just like we would a regular old equation. So we're going to ignore the fact really that there's an inequality sign there at all, right? We're going to look at the number that's over here with our variable. And we know that we will undo addition with subtraction. So we're going to subtract 8 from each side. Right, whatever we do on one side, right, there's really this line sort of going down here. Whatever we do on the right side, we also have to do on the left side. We know that these will cancel. And then instead of bringing down an equal sign, now we're just going to bring down an inequality sign. So we have a -10 minus 8, which will give us a -18. Now we've already talked about graphing these, so to put this on our number line, right, -18 is going in the middle. Remember, with number lines, they feel a little bit backwards. So -17 is over here, -19 is here. Because this has an or equal to, this would be a filled in circle. And then it is greater than or equal to, so we would shade that to the right. Okay. If we are solving 1-step inequalities that have subtraction, again, we are going to solve this like any regular equation. We're going to pretend just like it's an equation where we undo subtraction with addition. So we are going to add the number, whatever number is on the same side as the variable. And we're going to do that to both sides because whatever we do to one side, we have to do to the other. So if we have something like w minus 4 is less than -2. Okay, we have our variable. We will undo subtraction with addition, and we're going to do that to both sides, just like if it was an equation. So we know these will cancel. And again, we're just bringing down the inequality sign instead of bringing down an equal sign. And -2 plus 4 gives us a 2. So if we go to put this on our number line, we know that 2 is going in the middle. Okay, this gives us an open circle. And this is one that would be shaded to the left. Now, things start to change up a little bit when we're solving by multiplication or division. So on the bottom row of our chart here, we're going to have a little bit of difference. So if we are solving a 1-step with multiplication, okay, to undo multiplication, we are going to use division. So we are going to divide the number that's on the same side as the variable. And again, we're going to do that to both sides. But the key here is that if we end up multiplying or dividing, so in this case, we'd really be focusing on dividing, but by a negative, then we have to flip the inequality sign. So if there's a negative involved in that solving step, we have to flip the sign. So for example, if we have negative 2a is greater than 10. So just like our normal equations, we would undo this multiplication with division, and we're going to do that to both sides. 10 divided by negative 2 gives us a negative 5, but because we multiplied or divided by a negative, right? Right here we are dividing by a negative. That tells us the direction of our inequality sign needs to change. So I'm taking this sign and I'm flipping it. So when I make my number line down here, I'm going to have negative 5 in the middle. Okay, I have an open circle, but because I flipped it, I'm now going to be shaded to the left. Okay, and then finally on our last one-step equalities with division. Same idea, we undo division with multiplication. So we're going to multiply the number that is on the same side as the variable, and we have to do that to both sides. But again, that new rule says if we multiply or divide, this one we'll be more focused on multiplying, by a negative, so it has to be a negative that we're moving, then we are going to flip the sign. So if we have something like c over negative 4 is less than or equal to 5, right? We will undo our division with multiplication. So we're going to multiply each side by negative 4. These will cancel, but again, we moved a negative. So we're multiplying by negative, which tells us we have to flip the direction of that inequality sign. So on our number line, we'll put negative 20 in the middle. It feels a little bit backwards, but that's right. And we're going to have a filled in circle, and this one tells us to shade to the right. Okay, so if we look at some extra examples here, just to make sure we're clear on this, right? Basic addition and subtraction, our rules stay the same. We don't have to worry about the sign. So if we want to solve this, right, we're undoing addition with subtraction. We don't worry about the inequality sign. We just bring it down. We get W is less than or equal to 5. Number 2, right? We're undoing multiplying with negative 3 by dividing by negative 3. Now we're in the world of multiplication or division, so we have to consider, did we multiply or divide by a negative? Yes, we did. So we need to flip the direction of that inequality sign. Okay, on our next one, if we want to solve this, we have c divided by 5. Okay, so we're undoing division. We always undo division with multiplication. So we're going to multiply each side by 5. We're in the world of multiplication and division, so we have to decide, are we multiplying by a negative? Now, here we have to be a little bit careful, because while there is a negative involved with that negative 7, it's not the number that we're moving, right? We're multiplying by positive 5. So we do not flip the inequality sign on this one. Our 5 was positive, so that stays the same. Now, these can then turn into two-step equations, where we have to take the same steps with equations, but now apply the new rules we've just learned. So we know when we're solving an equation, we do order of operations backwards. So we're going to undo addition and subtraction first. So in this problem, we need to move this 11 first. So the 11 is positive, right? We're looking in front of it. We move a positive with a negative. 19 minus 11 gives us 8. We were dealing in the world of addition and subtraction, so we do not flip the inequality sign. What we have left, though, is now a negative a. So now we have a negative 1 sitting in front of this. That negative 1 is attached with multiplication. We undo multiplication with division. We're in the world of multiplication and division. We did divide by a negative, so this is a time that we would need to flip the sign. And so our final answer will be 8 is less than or equal to -8. Okay, on our next one, again, it's a two-step. So we want to undo any addition or subtraction first. So I'm going to subtract 13 from both sides, right? My 13 is positive. I undo a positive with a negative. Okay, this is going to leave me with a -7. I subtracted though, so subtracting has nothing to do with flipping the sign. So my sign is staying the same. Okay, my next step is going to be to move this 4. We undo multiplication with division. I am dividing by a +4, so I do not need to flip the sign. So now I have -7/4 is less than y. Now, -7/4, you could turn into a mixed number, you could turn into a decimal, but it is reduced in that format, so it's fine. But we've also said, right, a couple days ago when we were looking at our equivalent inequalities, we said our best answer is always when the variable is first. So we want to write our final answer with the variable first, which means we want to flip this. And if we rewrite this with the variable first, that is a reason to flip the sign. And so our final answer will be y is greater than -7/4. Okay, our next one, we have x plus -4, all divided by 3 is less than -8. So this is one of those situations we said, right, where we really have parentheses on top. So order of operations backwards, parentheses are now going to come last. So we have to move that 3 first. So we'll undo dividing by 3 by multiplying by 3. This 3 has nothing to do with that numerator, so those 3's cancel. Right, we multiplied by a +3, so that was not a reason to flip the sign. That 3 was positive. Doesn't matter that the 8 was negative, only matters that the 3 was. Okay, if the 3 is positive, we don't flip the sign. Oops, I brought this down wrong. Sorry, that's an addition sign. Okay, now we need to move that -4. If we look in front of the -4, it's addition. We undo addition with subtraction. Okay, these will cancel each other out. And so we will get x's over here, right? If we do the math, you change it to adding the opposite, whatever, we get -20. That was in the world of addition and subtraction, so that is also not a reason to flip the sign. So then in our last example here, we're talking about that explaining and justifying, which we did with the equations as well. We just now have this added component of thinking about what is happening with the inequality sign as well. So if we start solving this, the first thing we're going to do is we're going to move our +32 by subtracting 32. Okay, so if we take that 12 minus 32, we're going to get -20. That's not a reason to flip the sign. So -20 is greater than or equal to -5c. So we can use our same justification we did with equations, right? I subtracted 32 from both sides. And maybe this time, right, I don't really see an addition sign, so I might have to say because subtracting is the inverse operation of a positive. Okay, then we're going to go to our next step. Our next step is going to be, okay, I need to get rid of this -5. So I'm going to undo multiplication with division. I'm dividing by a negative, so that is a reason to flip the sign. Right, so I divided by -5 on both sides. Because division is the inverse of multiplication. But I might also need to write, I flipped the inequality because I divided by a negative. Oh, I'm going to have to squeeze this in. Now, we're not quite done on this one yet because for our final answer, we really truly want to have that variable first. Okay, so we might have to have a final step, okay, where we are rewriting. Oh, I rewrote? I don't know if that's a word. All right, we're rewriting to have that variable first, okay? So there's our sort of explanation and justification there.